The Octoverse, I just heard about. It's a annual survey of things that GitHub does. GitHub is a big coding repository on the internet, and the last one they did for coding language popularity was in 2022, and Java is still a high-end language, but there's a little graph that I wanted to share you. You'll see this again on Thursday, but JavaScript, most popular language according to their survey. Python, the second. Java, what you did all year, the third, which is awesome. And this thing called TypeScript is the fourth. And what's kind of cheating about that is TypeScript is actually just another version of JavaScript. So JavaScript is way the most popular. And then it goes down from there. Anyway, interesting. I like that it, Java went down a little bit, but it's still up high. And they even have an article up here. After nearly 30 years of Java, you might expect the language to be showing some signs of wear and tear, but nothing could be further from the truth. Anyway, today I'm going to talk briefly about binary numbers, something that that we haven't done this year. It's not what? We're not going to talk about that today, but I think we do that in the book. And then we have a worksheet where we're going to do some binary math. And then we're going to read code the book chapter 3 and code the book chapter 4. And then there's little things I need you to do in response to that. So let's start with this statement. It'd be great if you all could look up here. I don't know what you're doing, but I can't see a lot of your eyes, which means you probably can't see me. There's only 10 kinds of people in the world, those who understand binary and those who don't. So if you understand binary, that you find that a little bit funny, but let's talk about it. Our regular number system is called decimal, which means base 10. And the way base 10 works is each digit as you move left in a number is worth times 10 more than the previous one. So really the ones digit is 10 to the 0. The tens digit is 10 to the 1, and the hundreds digit is 10 squared. So see, 543 is really 5 times 100 plus 4 times 10 plus 3 times 1, because 10 to the 0 is 1. I know I'm going fast, but I think you've seen these concepts before. So computers internally use base 2, which is called the binary number system, which means numbers are written as either ones or zeros. And I think deep down, my understanding of it is really this is because electronically, you can have a mechanical or software switch that's either open or closed. Open or closed, can represent on and off very easily.
They also use high voltage and low voltage.
Or high voltage and low voltage. So if we have a binary number, it's just going to be made up of ones and zeros. The first digit on the far right is either going to be 1 or 0. The second digit will be a 1 or a 0, but it stands for 2. The third digit stands for 4. The next digit stands for 8. So it's powers of 2 going up from 2 to the 0. So 1, 2, 4, 8, 16, 32. You can figure it out. I'm going to give you a couple examples, but here's a little animated example. This is counting up in binary. 8 and 9 is a 8 and a 1, and 10 is an 8 and a 2. And anyway, this is a little GIF I found, which I think is kind of fun. Some of you may have seen my clock. I haven't set this for months, but right now it's showing 10:05. So it's a little off. What do we want? 10:30. I don't have the second set right, but it's set to 10:30 now. You can look at it sometime if you want. The top two lines represent the ones and the tens and the ones digit. So we have a 1 and a 0 for the hour. And then the next row is a 2 and a 1 adding up to 3, stands for 30. And then the bottom is the seconds, which are just constantly changing. So everyone, back to the opening joke. And I put joke in quotes because it wasn't really funny, but there are only 10 kinds of people in the world, those who understand binary, those who don't. That's because 1, 0 means the number 2. So there's 2 kinds of people in the world, right? Those who understand it and those who don't. Let's do some conversions. What is 1011 in decimal? I wrote out 1011 and I wrote 1248. And basically, this is how I do it on paper anyway, or in my head. There's a 1-8 plus 1-2 plus a 1-1. So I have 8 plus 0 plus 2 plus 1 equals 11. Anyone have a question about this? A bigger number, you got to go further. So this one goes all the way up to 64. So we got a 64 plus 0. There's no 32s, but there's 116, there's 1-8, there's no 4s, and there's a 2 and a 1, and that adds up to 91. I'm not going to, you're going to be doing simple arithmetic today. Going the other way, 22 decimal, changing it to binary. The way I do it usually is I look at the powers of 2 and I figure out what's the biggest one that would go into the number 1 time plus some change. So like we don't want to say, oh, 22 has 2 8s. That doesn't help us. We want to know, hey, there's 116 in there. So I look at the list. I say, hey, 16 is the biggest power of 2 that fits totally inside of 22. So 22 minus 16 leaves us 6 remaining. And then you can get 6 by adding 4 and 2. This thing's in the way. Come on. Hi, buddy. Go figure. It doesn't behave like a normal button. There we go. So 16 plus 4 plus 2 is 22. And this is what it looks like in binary. And we got one more. What's 131 in binary? So I just make the list bigger. And it's just you keep doubling the numbers. So the biggest power of 2 that is less than 131 is 128. So 131 minus 128 is 3. So we're going to have a 128 and then a bunch of zeros and then a 2 and a 1. And you get this crazy number. Questions? There's another way to do it. And I linked it to you. It's actually pretty fascinating. Where you just divide by 2 over and over and over again. And and you write down the remainder, and it works too. And in fact, that's what we'll do. Friday, we're going to write a program, and we'll do it that way. But today, we're just doing stuff on a worksheet. So come on, you little monster. I guess I'm done.